Good morning, students. Welcome to the class 9C. I, Mrs. Anju Farkade, will teach you maths for this academic year 2020-21. Now, let us begin with the algebra chapter. The first chapter is sets. Now, look at the pictures which are given below. It contains a group of things. Now, the first one is a flower bouquet. Second one, the bunch of keys. Third one, the flock of birds. Fourth one, the pile of notebooks. And fifth one, the collection of the numbers. So, we use a special word for each of the collections given above. So, the collection of these objects, this is called as the set. So, the flower bouquet, it is a set of flowers. Bunch of keys is the set of keys. Then flock of birds is the flock is the set collection of or the set of birds. Pile of notebooks is the set of notebooks, and the numbers 1 2 3 4 5 and all, these are the collection set of numbers. So how we can define this set is defined as the collection of the such objects is called as the set. Now observe another collection like the happy children in the village, brilliant students of the class. Now happy and brilliant, these are the relative terms because the exact meaning of these words to be happy or to be brilliant differ from person to person. Therefore, these collections are not set. Now see some examples which are given below and decide whether it is a set or not. Now days of the week, now the total 6 examples are given. The highlighted ones, these are all the collection or these are all the examples of the set. Like days of the week, 7 days of the week are there. So this is the set. The months in year, 12 months are there, January, February, March, April up to December. So this also is the set. Then third one, brave children in the class. Now brave, it is a relative term because the exact meaning of this brave, it is differs from person to person. So the brave children in the class, here this cannot be a set. Then first 10 counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the set. Then strong forts of the Maharashtra. Now strong, it is also the relative term because that also differs from person to person. So that also cannot be called as the set. Then planets in our solar system, total 10 planets are there. So that also is the collection of set. So out of these 6 examples, we can see now the highlighted ones here. So these 4 are the examples of the set. Now next, let us consider this one, how to denote the set. Now the name of the set, it is given by using the capital letters of the alphabet from A to Z. Now the members or the elements of the set, they are shown by using the small letters like A, B, C and so on. Now here let us use this symbol. If A is an element of the set A, then we write it as A belongs to A. So this belongs to, this is the sign, A belongs to set A. And then if A is not the element of the set A, then we write it as, put a stroke over that belongs to sign so that denote it does not belong to. Now let us observe the set of the numbers which are given below. Now there are different sets of numbers. So the set of natural numbers, it is denoted by capital N. Now this curly bracket, it is used for denoting the sets. So this inside the curly brackets, all the elements, they are written one after the other, separated by the commas. The set of natural numbers, it begins from 1, 1, 2, 3. Now infinite numbers, set of natural numbers are there. So we put dash, dash, dash and close the bracket. Then W is the set of whole numbers. So when 0 is included in the set of natural numbers, then it becomes the set of whole numbers. Then I is the set of integers. So now set of integers means minus dash dash dash, put -3, -2, -1, 0, 1, 2 and put dash dash is the set of integers. Then Q is the set of rational numbers. Rational numbers consist of integers as well as fractions. Then R is the set of real numbers. Real numbers consist of rational as well as the irrational numbers. Now there are 2 methods of writing down the set. First is the listing method or the roster method. Now listing method means from the name itself you can understand. In this method, all the elements of the set, they are written one after the other and separated by the commas. So the order of writing down the elements is not important. All the elements should be there. They can be written down in any order. For example, now consider this one. The set of odd numbers between 1 and 10, it can be written as a is equal to 3, 5, 7, 9, or it can also be written as 7, 3, 5, 9. So the order of writing down the numbers is not important. Only thing is that all the numbers or the elements should be there in that given set. Now, if the element it comes more than once, then it is customary to write down that only once. For example, now one more example you see here. This one, remember. If you are writing down the set of example in the word remember, the letters R, M, E are repeated more than once. So the set of letters of the word is written as A is equal to REMB. Means RM is, though it is repeated, so it will be written down only once. The set A will have only 4 elements R, E, M and B. I hope it's clear to all of you now. Now let us see the next method of writing down the set, that is the rule method or the set builder form. So rule method or the set builder form, again from the name you can understand. Rule method means here the rule by which the given elements are there in the given set, that we have to write down that rule. So in this method here, what we do not write down the list of the letter, but we write down the general element using the variable followed by the vertical line or the column, and then write the property of the variable. Now for example here, this one, consider this one, this example, A is equal to X is the set of the line is there, stroke line is there, so that is how we read it. This one, X belongs to N, X is greater than 1 and less than 10. Now this set, it is written in the set builder form. So in the set builder form, and how we read it, set A is the set of all X such that X is a natural number between 1 and 10. I hope it's clear to all of you now. Now let us go to the next example. Now set B, you see it is a set of all X such that X is a prime number between 1 and 10. So now set B consists of all the prime numbers between 1 and 10. So this set B will have the elements 2, 3, 5 and 7. So now next here, now let us compare these examples here. Some examples are written by both the methods. Now here consider the first example now. A is the set of all X such that X is the letter of the word division. Now again in division you can see D, this one I, then S, I, O and I and O, they are repeated. So only by resisting method, only this one, these the remaining letters will come, D, I, V, S, O, N. Then B is the set of all Y such that Y is a number such that Y square is equal to now 9. Now we know that now this is the set builder form of the given set B. So the same set B in the listing method, how we will write down? B consists of 2 elements, -3 and 3, because -3 square is also 9 and 3 square is also 9. Now C is the multiple of 5 and less than 30. Now less than 30 it is, means here which multiples of 5 will come? 5, 10, 15, 20, 25. Less than 30 it is there, so 30 will not be there. If less than or equal to 30 would have been there, then 30 also we have to include in this set C. Now here are some more examples. Just fill in the blanks in the following table. Now these blank spaces I had already filled up. You just go through it. Now in the first column it gives you the listing or the roster method elements, and the second column it gives you the rule method. Now A is equal to 2, 4, 6, 8, 10, 12, 14. Now find out the common property or the common rule by which each of this element is a number is the element of the given set A. So what do we see? 2, 4, 6, 8, these are all the even natural numbers. So how you will write down by rule method? A is the set of all X such that X is an even natural number less than 15. Got it? So that is the common rule by which all these elements 2, 4, 6, 8, they are belonging to the set A. Now second one you see here, B is the set of all X such that X is a perfect square number between 1 and 20. Now between 1 and 20, 4 perfect square numbers are there. numbers are there which are perfect squares. So what elements of B will be 1, 4, 9 and 16. Then see the third example now. C is equal to A, E, I, O, U. Now A, E, I, O, U, these are the vowels. So C is the set of all X such that X is a vowel. Then set D, you see D is a color in a rainbow. Now in a rainbow, how many colors are there? 7 colors are there. So that's why here violet, indigo, blue, green, yellow, orange and red. This will be the, now this though I have written down in short V, I, B, G, Y, O, R, but actually you must write down the full word of these spellings of these words: violet, indigo, blue, green, yellow, orange and red. Then B is the set of all X such that X is an integer and minus X is greater than -3 and less than 3. So here which one will come here? So greater than -3 means -3 will not be there. -2, -1, 0, 1, 2, this will be the elements of set P. Then set M has got 1, 8, 27, 64, 125. Now 1, 8, 27, 64, 125, these are the cubes of the number. So now here this one, if you will write down, M is the set of all X such that X is equal to here this number, this one, X is equal to N cube will be there, and then N is equal to N is equal to 1, 2, 3 and so on. So these are all the cubes of the number. So I hope it's clear to everyone now. Now let us see, now this practice set we will solve later on. Now let us see the explanation for the other things. Now next we will see the types of the sets. Now the name of the set, definition and the example is given. Now these are the different types of the sets. First is the singleton set. Now the set consists of a single element is called as the singleton set. Now A is equal to, A will have only single number, that is 2. Then A is the set of even prime numbers. Then second one is here the empty set or the null set it is called. If there is not a single element in the set which satisfies the given condition, then it is called as the null set or the empty set. Null set, it is denoted by only the curly brackets you put, or you use this symbol here, this one, which is called as phi. Now example of the empty set is here this one. X is a natural number between 2 and 3. Now there is no natural number between 2 and 3. So this empty set B, you will denote it as B is equal to this empty set, or this phi symbol you will use. Phi is the Greek letter. Then finite set. If the set is a null set or the number of elements are limited and countable, then it is called as the finite set. Now C is the number from 1 to 22 divisible by 4. So 1 to 24 divisible by 4, which numbers will come? 4, 8, 12, 16 and 20. Then infinite set. If the number of elements in a set is unlimited and uncountable, then the set is called as the infinite set. So n is equal to 1, 2, 3, 4 and dash. So now I hope it's clear to all of you all the different types of sets. Now after this, now let us see equal sets definition. Now two sets are said to be equal if every element of set A is in the set B and every element of set B is in the set A. So set A and B are equal sets. Symbolically it is written as A is equal to B. Now consider this example now. A is the set of all X such that X is a letter in the word listen. So set A will have the elements L, I, S, T, E, N. Now B is the set of all Y such that Y is the letter of the word silent. Then the B will have the elements S, I, L, E, N, T. So what we observe in A and B have got the same elements. Though their order is different, but they have got the same elements. That's why here these two elements of both the sets A and B, they are not in same order, but all the elements are identical. So they are called as the equal set. So A is equal to B. Then one more example you see here, this one, example 3 now. Now set A has got the elements 1, 2, 3. B has got the elements 1, 2, 3, 4. Now both are not having the equal elements, so A is not equal to B. Now X here, next we will see here now Venn diagrams. Now see, anything British logician John Venn, he was the first to use the closed figure to represent the sets. So such represents, they are called as by his name Venn diagrams. So Venn diagrams, they are very useful in order to understand and illustrate the relationship between the sets and to solve the examples based on it. Let us consider the use of Venn diagrams for the following examples. Now set A. Set A, it is equal to, it is having the elements 1, 2, 3, 4, 5. Now these Venn diagrams, they can be represented by ovals or by circles, or you can use rectangles for denoting them. So draw the oval like this and then denote it by the set A. Inside it, write down all the elements and show it them by the dots. Now see here, this one set B. Set B, it is the set of all x such that x is greater than or equal to minus 10 and less than or equal to 0. This is the less than or equal to sign, means minus 10 integer will also be there. So the elements of the set B will be here now minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 3, minus 2, minus 1, and then 0 will also be there, because here we can see x is less than or equal to 0, it is there. Now this Venn diagram, it is shown by using the rectangle. Now next definition is here subset. If A and B are given sets and every element of set B is also an element of set A, then B is the subset of A. Now which is symbolically written as B is the subset of A, and it is read as B is the subset of A or B is the subset of A. Now here see, consider this example now. Set A has got the elements 1, 2, 3, 4, 5, 6, 7, 8. Now B has the elements 2, 4, 6, 8. Now every element of set B is also an element of set A. So B is the subset of A. So this is the subset sign. This one, this is B is the subset of A. It is understood like this. Now let us see this one. So this how you will represent it using the Venn diagram. Since B is the subset of A, B will lie inside A, and all the elements of B you write down first, 2, 4, 6, 8, and then the remaining elements of A which are not there in B will write down outside B. So this is how to represent the B is the subset of A. Then one activity is there. Now set of students in a class is there and the set of students who can swim. Now the students who can swim, that set will come inside the set of students in a class. Now same way here you can draw the Venn diagrams for this activity here. Remaining examples are given. So for this also you can write down the activity, complete this activity, draw the Venn diagrams for this. Now let us consider. So I hope all these now, so remember this now, every set is the subset of itself, means A is the subset of A. Empty set is the subset of every set, because empty set does not have any elements, it will be the subset of all the sets. If A is equal to B, then A is the subset of B and B is the subset of A. If A is the subset of B, then B is the subset of A, then A is equal to B. So remember these points, this also we will be using later on. Then next after this here, let us consider what do you mean by the universal set. Now universal set means here, think of a bigger set which will accommodate all the given sets under condition, which in general is known as the universal set. So that the set under consideration are the subsets of the universal set. Suppose we want to study the students in class 9 who frequently remain absent. Then we have to think of all the students of class 9 who are in the school. So the students in a school are the students of all the division of class 9 in a school. These are the universal set. Then another example you can take here, this one. The team of cricket players and all the students in a school who play cricket. Now the universal set, it is generally denoted by U, and in Venn diagram it is represented, and in Venn diagram it is represented by the rectangle. So this you remember. Now next we will see next definition, now the complement of the set. Suppose now U is the universal set, and if B is the subset of U, means all the elements of B are also the elements of U, then element in U, then which is in set B, this is called as the complement of B, and it is denoted by B dash or B and small c we write down at the top. So definition of the complement of the set B dash, it is written as B is the set of all x such that x belongs to U and x does not belong to B. So let us understand with this example. Now universal set U is there, which has got the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A has the element 2, 4, 6, 8, 10. Then A dash, except this 2, 4, 6, 8, 10, whatever elements are there in U, that you write down in A dash. So 1 will come, then 3 will be there, 3, 5, 7 and 9. This will be the elements of A dash. Now consider the second example. Suppose U is now this same thing how you will represent by using the Venn diagram. Consider this one universal set, it is denoted by a rectangle. Write down, take a circle or oval inside the universal set which denotes the set A. So set A, write down all the elements 2, 4, 6, 8, 10. Now remaining elements of the universal set, that will consist of A dash. So this shaded portion now it represents A dash. So this is how you can represent this Venn diagram for the complement of the set. Now consider this example. Now another example, universal set U, it has got the elements 1, 3, 9, 11, 13, 18, 19. B is equal to 3, 9, 11, 13. B dash is equal to 1, 18, 19. Now find the now see this, how to read this? Complement of the set and draw the inferences. Now complement of the sets is the element which are not in B dash but in U. So is the complement of B dash is equal to B? That let us understand this with the help of Venn diagram. Now this is the set B. Now set B is there, it has got the elements 3, 9, 11, 13. Now remaining elements of the universal set, that will come outside B. So that this shaded portion now, here it represents B dash, and this is the universal set. So thus what we say, that the complement of the set, complement of complement is the given set itself. Now properties of the complement of the set, no elements are common in A and A dash. A is the subset of universal set, A dash is also the subset of universal set. Complement of the universal set is empty set, and complement of the empty set is the universal set. So I hope it's clear to everyone now. Now begin with the practice set 1.1. Write the following sets in the roster form. Roster form means in the listing form. Now set of even natural numbers. Now even natural numbers begin with 2. So denote this set by A. So A is equal to 2, 4, 6, 8. Now second one is set of even prime numbers from 1 to 50. Now from 1 to 50 there is only one even prime number. So B is equal to 2. Otherwise also there is only one even prime number, that is 2. Now third example is set of negative integers. I is equal to minus 3 dash 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 minus 3 minus 2 minus 1. Only the negative integers will be there. Then 7 basic sounds of sargam, that is the sur. Now let us denote this set by S, and the 7 surs are sa, re, ga, ma, pa, da, ni. So these are the 7 sargams. Now second example is write the following symbolic statements in words. 4 by 3 belongs to Q. So in statement it will be 4 by 3 belongs to set Q. Minus 2 does not belong to set N. Then P is the set of all P such that P is an odd number. P is the set of odd numbers. Now let us see the fourth example. Write the following sets by using the listing method. Now set of letters in the word complement. Now in the letter complement, now A is equal to C, O, M, P, L, E, N, T. Now M is repeated, so M is written down only once. Now next is set of human sensory organs. Now human sensory organs, there are 5 human sense: eyes, ears, nose, tongue and skin. Then next we will see the fifth sum now. Write the following sets using rule method. Now in rule method, now see the set A. Set A has got the elements 1, 4, 9, 16, 15, 30. These are all the squares of the numbers. So how you will denote them? A is the set of all x such that x is equal to n square and n is greater than or equal to 1 and less than or equal to 10. Then B has the elements 6, 12, 18, 24, 30, 36, 42, 48. So B is the set of all x such that x is equal to 6n, n is greater than or equal to 1 and less than or equal to 8. Then x is equal to AET. So x is the set of all x such that x is the letter in the word eat, or t also you can take, or 8 also you can take, ATE 8. Now let us see the next one, next practice set. Decide which of the following are equal sets and which are not. Justify your answers. Now A is the set of all x such that x is equal to 3x minus 1 is equal to 2. B is the set of all x such that x is a natural number but x is neither prime nor composite. C is the set of all x such that x belongs to n and x is less than 2. Now solve the first example and you will get x is equal to 1. Now set B is a natural number which is neither prime nor composite, means again B will also have the element 1. And C is the natural number less than 2, means again C will have the element 1. So what we see from this, A, B, C, these are the equal sets. Now the third example, you see which of the following are empty set and why. A is the natural number smaller than 0. Now there is no natural number smaller than 0, so A is an empty set. Then B is the set of all x such that x square is equal to 0. Now 0 square is equal to 0. So the element of B will be 0. So 0 is an element. So B is a singleton set, but it is not the empty set. Then C is the set of all x such that x is 5x minus 2 is equal to 0, x belongs to n. So 5x minus 2 is equal to 0, x is equal to 2 upon 5. Now 5 is a natural number. 5 x is equal to 2 upon 5 we get, but what is given condition here, that x is a natural number. So again this set will be a empty set. So C is an empty. Now state with reasons which are whether the following sets are finite or infinite. Now finite or infinite means if finite number of elements are there, then finite. If infinite number of elements are there, then infinite. Now A is the set of all x such that x is less than 10 and x is a natural number. So A is equal to 1, 2, 3, 5, 6, 7, 8, 9. So A is a finite set. Then B is the set of all y such that y is less than minus 1 and y is an integer. Now there are infinite numbers of integers which are less than minus 1. So B is an infinite set. Now set of people from your village. Village will have a particular or the finite number of people. So a set of people from your village is also a finite set. Now next you see the practice set 1.3. A has the elements A, B, C, D, E. B has D, E, E, F. C has B and D. D has A and D. You have to write down which of the statements are true. Now here this exercise is based on the subset relation. Now subset relation, you know that if all the elements of A are the elements of B, then A is the subset of B. So C is the subset of B. This is because all B and D are also the elements of B. So B is the subset of C is the subset of B is a true statement. Then A is the subset of D. Now all the elements of A are not the elements of D. So D is the subset of A is the subset of D is a false statement. Then D is the subset of B. So all the elements of A are not the elements of B. So the D is not the subset here. So that also is the false statement because A is not there in B. Then D is the subset of A. Here this is the true statement because A and D are also the elements of set A. Now B is the subset of A. B is the subset of A. This is the false statement because F is, see here this one, F is there in B but then F is not there in A. So all the elements of B are not the elements of A. So B is the subset of A is the false statement. Then A is the subset of C. There again that is the C is the subset of A is the true statement because B and D are the elements of C. They are also the elements of A. So that also is the true statement. Now take the set of natural numbers from 1 to 20 as a universal set and show set x and y using the Venn diagram. Now x is the set of all x such that x belongs to n and x is greater than 7 and less than 15. So what we see here, and y is the set of all y such that y belongs to n and y is a prime number from 1 to 20. Now universal set U is equal to, we'll have all the numbers from 1 to 20. X will have the elements from 8, 9, 10, 11, 12, 13, 14 and so on. Now this one, Then this Venn diagram, you see x is equal to 8, 9, 10, 11, 12, 13, 14, y is equal to 2, 3, 5, 7, 11, all these numbers. So now 11, and so draw the universal set U denoted by the rectangle, and then inside it take two circles x and y, and then show these all the 11 and 13 is common. So in the common part you will show the write down the elements, common elements 11 and 13. Now remaining elements of x you will write down in this circle, remaining elements of y you will write down in this remaining part of y, and whatever elements are there which are not there in x as well as in y, that will you will write down in this rectangle in the remaining part of the universal set. Now next is here this one complement. This example it is based on the complement of the set. Now complement of the set definition we have already seen. Now universal set U is equal to 1, 2, 3, 7, 8, 9, 10, 11, 12. So P is the set of P has the elements 1, 3, 7 and 10. Now show the sets U, P and P dash by Venn diagram and verify that complement of the set is equal to P. Now first you draw the rectangle, use the rectangle for the universal set, and inside it take the circle for denoting the set P. Now set P you write down all the elements 1, 3, 7 and 10. Now whatever remaining elements are there which are there in the universal set but not in P, that you write down in the shaded portion. So this shaded portion now it represents the set complement of the set P dash. So P dash will have the elements 2, 8, 9, 11, 12. Now again find out its complement, means all the elements of P dash universal set which are not there in P dash. So again 1, 3, 7, 10 will come. So what we see, complement of the set is equal to the given set. So this is also defined. Then let all the students in the class is an universal set. Let set A be the students who secure 50% or more marks in maths. Then write the complement of the set A. A dash is the set of students who secure less than 50. So now most of the sums I have done from the 3 exercises. Now let us